What's up, everybody? This is 9.7, and it is about natural logarithms. 9.7, natural logarithms. Natural logarithms. So we kind of touched on this last time, but a natural log and what it is, it's a log function with a base e. So normally we're just like, hey, if there's no base, we say the base is e. But if we have log with a base e of x, that is going to turn into the natural log, so ln x. And you may be thinking, hey, natural log, why is it log natural? Well, in Latin it's called logarithmic naturale or something like that. So that's why it's ln. But whenever we have an e as a base for our log, it becomes the natural log. And actually, on our calculator, the natural log button is right below the log button, ln. And the thing that is nice with natural logs is they share all the same properties with regular logs. So product property if we remember, addition means multiplication. Well, same thing here. Natural log x plus natural log y is just the natural log of x times y. So, same property. Addition and multiplication go together. For quotient property, we said that subtraction and division go together. Well, same thing here. Natural log x minus natural log y is equal to the natural log of x divided by y. So addition and multiplication go together, subtraction and division go together. Power property, same thing as regular logs. If I have the natural log of a raised to the p power, I can take this and move it out front. So this is p times the natural log of a. So right now, those three properties are exactly the same thing. Our inverse property is when I have the natural log of e raised to the x power, raised to the x power is equal to x. The reason for that is because natural log is really just log of base e of e raised to x equals x. And if we remember from our regular logs, this e and this e, if these are the same base, this base and the number, those can just cancel out, and we're just left with x is equal to x. It's just left with x. Or, so that's one of our properties, one of the inverse properties. The other inverse property is if I have e and it's being raised to natural log x, natural log and e can just cancel out, and we just have x. So if you have a natural log and an e right here, completely cancels out. If we have e raised to a natural log, that's going to cancel out. And then finally, if is our duh property. Duh property, because it should be obvious. If we have if we remember, if e raised to m is equal to e raised to n, well, those can cancel and we can just have m is equal to n, kind of like dropping logs. Similarly, if we have the natural log of x equals the natural log of y, really that's just log base e. If a natural log is just log with a base e. We got logs on both sides, cancel, cancel, x is equal to y. So these are really the same properties that we learned about when we were dealing with logs. So for example number 1, I need to expand the natural log of x cubed y. So if we're expanding it, that means everything's going to get a natural log here, or a log. So really this is x cubed times y. Expand that, multiplication means addition. So natural log x cubed plus natural log y. And when we're expanding, we're not allowed to have exponents. So I have to use the power property to take care of this, to move this right in front. So we have 3 natural log x plus the natural log of y. And that's it. We just expanded it. For number 2, I want to condense. So condense means get small. We should only have 1 log left. We want to condense 3 natural log x minus natural log 2. So kind of we have to go in reverse order. That means I can have exponents. I'm going to take this number right in front and move it as an exponent. So I have the natural log of x cubed minus natural log 2. So now I don't have any numbers in front of my natural logs, but I have subtraction, which is our quotient property. Subtraction means division. So natural log x cubed over 2. And that's it. Not too bad, if I do say so myself. Alright, so if we remember our change of base, if we remember that, if we have log base b of a, that can be written as log a over log b. So log of my big number over log of my base. I can also use that as natural logs. And actually these are the same thing. So if I have log base b a, so same thing, I can also write that with my change of base as the natural log of a divided by the natural log of b. And you actually wind up getting the same thing. So let's try that with number 3. So if I have log base 3, 7, I can write this as the natural log of 7 over the natural log of my base. So if I go into my calculator, natural log button is right underneath my log button. Natural log 7 divided, or close that parenthesis, divided by natural log 3. And I know it's hard to see in my calculator because it's kind of bright. But make sure you're closing that parenthesis. And let's just round 2 decimal places and we get 1.77. So that's easy. Alright, for number 4, I have 4 e raised to negative 0.3x minus 7 equals 13. Wow, that escalated pretty quickly, but don't worry, we know how to solve this. Let's just try to get e by itself first. So what we should do is add 7 to both sides. So those wind up canceling. And we get 4e negative 0 raised to negative 0.3x equals 20. We'll just pretend like this negative 0.3 doesn't exist. How to get e by itself? We would divide both sides by 4. So I get e raised to negative 0.3x is equal to 5. This is an exponential form, right? Because we have e and it's being raised to an exponent. Well, let's change this to log form. If I have log base e of 5, that's equal to negative 0.3x. And what's cool, I think it's cool anyway, if we have log base e, we know what that is. Log base e is just the natural log. So the natural log of 5 is equal to negative 0.3x. How do we get x by itself? Well, we'll divide both sides by negative 0.3. Please make sure when you go to your calculator, natural log 5, close that parenthesis, divided by negative 0.3. Round 2 decimal places, and we get x is equal to negative 5.36. So it may look intimidating, but I promise it's not that bad. So a lot of this stuff is just kind of using all the tools that we've learned previously and just applying it just a little bit differently. And last example that I think we are going to wind up doing for the year, which is actually really sad, to be honest. Number 5. It's my favorite number. Natural log 5 plus natural log x equals 1. So, first, I can't cancel logs because I have logs on on the same side. I'm going to have to condense. Addition means multiplication. So, the natural log 5 times x is 5x equals 1. And this is in log form, right? Let's turn this to exponential. So now I'm kind of working opposite. The natural log, I can just write as log base e. So that's 1. Log base e, 5x equals 1. So I just changed the natural log into log base e because those two things are equal to each other. And now it's in log form, I can change this to exponential form. Saying e raised to the power of 1 equals 5x. To get x by itself, I'm going to divide both sides by 5. And you may be thinking, why e to the first power? Why do I just put e? Well, you can, but if you go into your calculator, the e button is if you press second and then natural log. It's automatically going to be raised to an exponent. So just raised to the first power. And then divided by 5, the whole thing being divided by 5, we get 0.54. Just round 2 decimal places. And that will do it. Hope you guys are doing well. One thing I've been doing during quarantine has been doing puzzles. These are the 3 puzzles I've done.
the the two on the left are 1,000 pieces. Baby Yoda was 500. And that's super lame. I do math and I do puzzles. Sue me.